So today, I think we're ready to get started on our 350 block here for the 67 Camaro is where this is going to go. I have a set of main studs here and I have my caps over here, and we want to put these on and torque it down, check the mains, make sure they're as good as we think they are. I'm actually going to go through with just a little flat file here and just kind of hit all of the mating surfaces just to make sure there are no burrs anywhere that keep the caps from seating. And once I've done that, I'll put the studs in, we'll put the caps on, we'll torque them down, measure it up, see what it's like. I was going to let you start.
I don't have anything to say.
So anyway, last week, you know, when we tore down this motor, remember how nice the bearings looked after I don't know how many thousands of miles that engine had on it? Actually looks pretty good. I think he told me this had 200,000 miles on it. Some motor he was looking at had 200,000 anyway. I wonder really why this one was taken out of service.
Yeah.
And how nice the crank turned. I remember you commented about, you know, sitting there being able to spin the crank real nice. Well, it shows. Even after having put these main studs in, I have my gauge set so our tolerance is from -5 marks this side of 0 to +5 on the other side, which is 1,000th range, 5/10,000ths either way from 0. And right there I'm measuring just a couple 3/10,000ths from
the middle
of the range. That cap, I'm right on the tight side of the range. This one here, a couple tenths on the tighter side from middle. And when I check out around, they're relatively round. There I'm on 0 to a half on the tight side to still about a half there. This front cap right on 0. I'm just round everywhere I go and on size. I'm really quite impressed with the way the mains are measuring on this. So we're not going to have to do any line bore work despite having put different caps on it.
Well, not different caps,
different bolts.
Fasteners.
Yeah, different fasteners. You knew what I meant. Yeah, they're all, if anything. Anyway, I'm going to set this up and get it bored and decked. I want to deck this thing so with our combination of pistons, crank, and rods, I want to end up with about 45 thousandths quench. So I'll have to do a little figuring there, but I didn't want to take too much off the deck. Of course, I don't know where it is now, but if it's where I think it is going to be, I think I'm going to have to cut about 10 thousandths off the deck. And then I'm going to use a little bit thinner head gasket.
Okay.
And that way, in the future, should they ever have to deck this block again, they can just go back to a thicker gasket and still make everything work.
Okay.
So let me get this set up and we'll turn the camera back on when I'm ready to do that.
Okay.
We used to do a lot more high volume machine work and part sales, but these days it's more about custom or semi-custom machine work and engine builds, and of course sharing most of that with you guys here on YouTube. With everything evolving, it finally felt like time to update our website too. And instead of spending weeks messing around with layouts and plugins, I tried out the sponsor of today's video, Durable, an AI website builder. It's honestly wild. You just answer a couple of questions about your business and it builds a full website in like 30 seconds. I had a professional looking site before my coffee even got cold. But Durable's not just a website builder. Inside the platform, there's a tool called Studio. It's basically your own AI design team. You can instantly create logos, social posts, and all of your branded visuals. And it automatically keeps everything on brand so that it looks like your business. Studio already knows your business name and what you do, so all the images are tailored to your business. It will offer you templates to choose from, but you also have the freedom to make edits where you need them. They've even added AI chats, which is currently in beta. This tool offers built-in assistants that can help with marketing, customer messages, and general business tasks. It's kind of like having your own mini team that never takes a day off. And of course, every durable site is SEO optimized, so people can actually find your business on Google without having to dig through pages and pages of search results. If you've been putting off getting your business online or simply want to refresh your site like we did, try Durable today and use my code JIMS30 for 30% off all plans. You can literally have your new website live before launch. Thanks again to Durable for sponsoring today's video.
So just to run through this quickly, I know my stroke length on the crank is 3.48 inch, so I divide that by 2 is 1.740 inch. My rod length is 5.7. The piston we're going to use is 1.565 inch. So that means the total assembly height from the center of the crank through the rod to the pin of the piston on up to the deck of the piston there is 9.005 inch total assembled height. If I want an additional 40 thousandths for quench, I add that on, and then I'm also going to add a 5 thousandths fudge factor just in case we have any tolerance issues here. I would rather have a little too much than not enough, because if we don't have enough, that piston's going to hit the head, and we definitely don't want that to happen. So by time I take the 9.005 height of all my components plus 40 thousandths quench plus 5 thousandths fudge factor, that gives me a total of 9.050. Now then, we have to get that in relationship to the deck of the block here. We're also going to be using, I hope, a 30 thousandths thick head gasket. So if I take the 9.050, take away my 30 thousandths thick head gasket, that leaves me a height of 9.020 from the center line of the crank to the deck surface of the block here. Chevrolet blocks from the factory are supposed to be 9.025, plus or minus whoever happened to be working on it that day at the factory. This block, when I set my gauge and measured, is not quite, well, let's back up a little bit here. I measured this bank over here, and it's probably right on. This bank here is close to being right on at the front, but it's a little bit short back here at the back. It's just off ever so slightly. So anyway, I want to come out from the center line of the crankshaft to the deck. I want to have 9.020 inches. I can't measure to the center line of the crank, but I can measure to the top side of where the main bearing sits. So if I take away 1/2 of the bearing OD from my 9.020, half the bearing OD is 1.321, that leaves me a dimension of 7.699 from the top edge of my main bearing to the deck surface. And I have taken my deck gauge here, using a micrometer in here, or using a standard in here. I have got it set to where when I am right at 0 on this gauge, I will be right where I need to be. And I'm sorry, I have the camera on the wrong side. You can't see the face of the dial, but when I drop this down in and measure, like I say, to the top of that main, to the deck here, float this back and forth a little bit, find the smallest dimension is what I'm looking for. That way I know I'm square with the block. Takes just a little bit, pulling that back and forth. I need to take probably about 3 thousandths or so to take off in that area right there to get to where I need to be. So let's go ahead and make a first cut here, get it squared up, cleaned up anyway, and we'll measure again, see how close we are. I'm going to slip a little piece of paper under my cutter right there so I can feel when I'm ready to touch off with the cutter. And there it is. Just drags under there right now. Everything's mounted solid, locked down, should be ready to go. Okay, I'm in, just touching. 0. And let's give it, let's take 2 thousandths off, see how it looks. Okay, just as I had measured, this block is a little bit angled on this deck. I knew this side here seemed to already be a little bit shorter than this side over here. And that showed up here as I surfaced it. I made a 2 thousandths cut, and you can see it touched all over down on this side, and then a little bit up here, nothing over in this area. So the block was definitely off a little bit. So let me set that back up. We'll take a couple more and see what it looks like. I may put some color on there, put some of that red dye so it's easier for you folks to see. Okay, let's see what things look like after that pass. All right, you can see that we've cleaned up everywhere except a little bit back here on this corner. And we are clean in this area here and this area here where I'm going to set my gauge to measure the deck height. So let me set the camera back up over here and I will get that gauge out. And I would say we have got about, well, we are just about there. We are all but where we need to be. So I'm thinking if we make a 1 thousandths finish cut, that should clean this corner up, and we're going to call it good right there because we're not far off from where we need to be. Let me check one over here, see if it looks like we're getting the block square. And according to my gauge, we are. And like I say, we are just all but there already. So let's take 1 thousandths more and see if it'll clean up this corner, and we'll be good at that point as far as the deck goes. I'm going to slow the speed way down so we can get a nice finish, and we'll put this back on time lapse. We've made what I hope is the last pass on that side. And it has all cleaned up. See where we're at on our gauge here. Okay, I'm going to say we're about 2 thousandths below where we wanted to be, but that is exactly why we figure in the 5 thousandths fudge factor, because it took just a little bit more to clean this block than what we had to work with. I'm getting the same reading down here, so we are square. But yeah, just exactly 2 thousandths more than I initially wanted. But like I say, that's okay. So with that, I'm going to 0 my DRO. And at this point, we can change over to the boring head and get those 4 cylinders rough bored while we're set up on this side. So I'll let you watch as I change my setup here. I have to take off the milling head and install the boring head. This machine has a nice manual carousel here to hold the tooling. Take the last nut off here, raise the machine head up. The milling head stays behind. Make sure you always put the cover back on to keep dirt and cuttings out. Spin this around to our boring head. Make sure it's clean. lower down over the studs, and there is a pin here that's on a slot that has to snap into place. Our nuts back on. Snug those two down just a little bit. Raise the machine head up again. Carousel back out of the way. Last two nuts. Snug it down. And I'll just kind of visually align the block with the boring head. Sometimes if I actually go down a little closer, it's easier to get a visual on it. And viewers a lot of times ask why I don't start at one end or the other. I always start in a non-end cylinder. If it's 6-cylinder, I still wouldn't start on the end. Sometimes the webbing down in the block here is different on the very end cylinder from what it is on some of the others. For instance, this cylinder here, let me get the camera and I'll show you that. You can see there is nothing in the way at the bottom of that cylinder until you get way on down below. But this cylinder here has this piece right in this area here sticking out of the main webbing right at the bottom of the cylinder, where this cylinder does not. See, in that area there, my fingers fit back in, that's open, where this cylinder has that webbing. If I start on a cylinder like that and set my stop below the end of the cylinder and I move over to this one, I may set myself up for failure there and end up crashing. So that is the reason I don't start on an end cylinder, in case you were wondering. So I'll get my centering finger out, adjust the pointer to fit a cylinder of this bore size. I'm going to drop that down in maybe to about the middle of the cylinder. Set it in the slow speed here. There's a dial indicator up above here that will tell me when I'm in the center of the cylinder. I just have to move it back and forth in the XY axis a little bit until I find center. And that noise in the background is my gate alarm telling me somebody's coming through the gate. But the wind's blowing a little bit here, and I think it's just weed or something has found its way in there. Centered up. Actually, you gotta go turn that off. Tired of listening to that. We're going to attempt to make this block 20 over. So I have set my cutter in the micrometer here for the proper diameter, which is about 4 inch and 15 thousandths, because I want to leave a little extra to hone out of this block, since we will be using torque plates in case it distorts the cylinders significantly. It's a lot easier to hone a little extra than it is to wish you had the material to put back. And we need to set the depth. Find one of the longest points in my cylinder, which appears to be about 5 7/8 inch. I don't think there's any reason to go any beyond that. So over here on the side of the machine, there's a manual stop. I can set that to my 5 7/8. And with that, it does take, from where you set the stop to where the machine actually does stop, is probably close to 3/8 of an inch. So that'll give me a little bit of travel past anyway. The stop here needs to be moved, or safety, I guess you'd call it, to the Y-axis traverse down here so you can't accidentally traverse side to side. No heavier cut than we're taking. I'm going to run that about 550 RPM. Maybe I'll just manual feed this till it just touches off, just in case. Yeah, that sounds good. And there we are, making our first cut. Now listen. Okay, that one didn't change much. Sometimes it gets real quiet when you go past the top ridge and get into the worn portion of the cylinder. And I know this one is going to be close on whether or not we can make this happen with 20 over pistons rather than having to go to 30. I've got a little vacuum back here. I'm going to turn that on so it'll suck up some of the dust there. And probably wouldn't hurt for me to vacuum the floor here. A lot easier to keep the shop clean if you vacuum up as you go. I'm going to go ahead and set up the bore gauge so that when we get to the bottom of that cylinder, we can measure that and make sure our size is coming out where we anticipated it to be. Okay, I can hear the cutting stop there. Hopefully very shortly that will retract before it crashes in the bottom. And it did. In fact, I heard it just touch the bottom. There was one little clunk. So since it did reach all the way at the bottom, I'm going to raise that stop up slightly. And I need to finish setting up the bore gauge over here. Okay, it is roughly set to 20 thousandths. Let me zero my X and Y on here. Chevrolets are 4.4 inches in between center line of the cylinders. So if I move over 4.4, I should be very close when I start center up on that one again. But let's measure, see where we're at. And I have about 4 thousandths to go on that cylinder. Yeah, between 3 and 4. I might adjust that cutter back in just a little bit. I'd like to leave just a little bit more than that to hone out. Let's pull that cutter out, put our centering fingers in, and get this centered up before we forget. Okay, there we're on center with that cylinder. And I'm going to readjust my cutter for about 1/1000th less. That was an easy fix. Now we can run through all the other cylinders. Okay, that finishes our first 4 cylinders. However, this one here did not quite clean. I was a little bit afraid of that. Get the phone here where I can hold it and not shake so bad. I was afraid that wouldn't quite clean, but it's so close. I'll put the bore gauge in there and check, but I think by the time we get done honing the block, that will be completely gone. So let's flip the block over to the other side. I'll measure that in the process, and we'll see if we can clean up the other side just the same. So I have better than 4 thousandths to go through most of it there. So let me get up in that wear spot, see what it tells me. It is telling me that that is about 1/1000th deep. So with that only being 1/1000th deep and me having better than 4 to go, that will easily clean up in the hone and have us a good cylinder. No reason that can't clean. Let's move this block all the way to the right hand side here again. So to roll this over, I have to loosen this knob here, which is holding the triangle that creates the proper angle for the block. And then I loosen my clamps on either side here. And I should be able to roll this block back, get it close to where it needs to be, lock it back down, and clean up the cuttings that are down underneath here. Then I can flip this triangle the opposite direction from where it was on the other side of the engine. And we had the other side up. And when I bring that back up against the pan rails, that will create the proper position. So I have my 90-degree V between the two banks of the engine. And just as kind of a double check, I'll put the level on here, and it's relatively close. It is not going to be perfect unless the block is perfect, because we're not depending on having the block leveled any particular way. We're counting on it being indicated off of the pan rails down here with this triangle. And since I already have my stop set, I can start on this first cylinder and not worry about crashing, because I've already set everything up when I did the other bank. One thing I kind of forgot about on that other side until after I was already going was I need to chamfer the top of these cylinders. So I have a different tool here. It's just a 45 there. And I'll make a very light cut at the top there so that my rings will go in nice and easy. When I did the other bank, I noted the dimension on my DRO up here, so I know exactly how deep to cut to have all of them exactly the same. And here we go. This bank is not worn quite as much as the other side was, so I don't think we'll have any problem with the cylinders not cleaning on this side. So let me speed things along for you. All right, with that we have the cylinders rough bored. All 8 of them are done. Only the one that didn't quite clean up. So now we can switch the machine back over to the surfacing head and deck this side of the block. So let me show you that from a little different angle. I think at the beginning of the series here, when I changed from the surfacing head to the boring head, I did it from my right-hand side. So let me show you what it looks like from the left-hand side. Again, I just pull the carousel out. I've taken 3 of the nuts off, 3 of the 4 nuts off that hold the boring head. So I can lower this down onto the carousel till it just takes the weight off of it. Take off the last nut. Normally you always drop at least one of those, so let's see what happens before I get done. Raise the machine back up. Put the cover on so we don't get any dirt or cuttings inside the works of the boring head. Make sure this is clean. There is an indicator here that always has to be to the front. There we go, down over the studs. And there's a pin across in there we have to line up. Nailed it. Went right over it. Two nuts back on to hold it in place. We'll just Barely snug those. Raise the machine head back up. Carousel back out of the way. Last two nuts. And somehow I managed to get those changed without dropping at least one. So tighten that down. Disengage the down feed. Pull the safety out of the Y-axis feed. Put it back here in the X-axis down feed. And come down close to the deck surface. Get the right one here where the cutter is. Should be very close right there. Now I'm going to do two things here. I'm going to check this side again, see how much we have to go. If I recall, when I checked it earlier, there was about 5 thousandths that would have to come off. And I'd say yes, indeed. Five, maybe just slightly more than that, is our magic number. And the other thing I wanted to do is put some color on here to make it easier for you folks to see. So I'm just going to go around every cylinder and then around the perimeter. That should give you a good indication of what things look like as I make the cut. So there we are, ready to start. And on my DRO here, if I can get my legs untangled, you can see there is 13.5 thousandths to go in the Z-axis before I even touch off on top of the block. Or before finish size. That's actually not where I'll touch off. I'll probably touch off somewhere around 8 possibly. So let's start this up, see what happens. I need to go full speed. Okay, I'm thinking touching off at 8. Let's see what really happens. Touched off at 6. I can just barely hear that. Touching here on this corner ever so slightly. So let's go down to, let's take this down to 2. That would be about 4 thousandths cut. That shouldn't be too bad. And we'll see what it looks like. Okay, let's see what this looks like after the first cut. Well, that was 4 thousandths of an inch, leaving us 2 thousandths to go on this yet. And it is completely clean. This was a pretty nice block. Almost left a shadow up at that corner, but our final 2 thousandths will clean that. So I better measure and make sure we are coming out where I thought we would come out. And then we'll make our final finish cut. Okay, after measuring with the deck height gauge there, things are coming out exactly as I anticipated. So I'm going to make one more cut. I'm going to slow the traverse speed down so we can get a good finish. And we need to drop down 2 thousandths more and make our final cut. Now my camera is running low on batteries, So I'm going to shut this off and we'll come back after this cut is done. Measure it one more time. Okay, there we have our block pretty well finished. I probably will come back with a countersink bit and chamfer the top of some of these bolt holes and some of the holes here like where the dowel pins go in. But other than that, the machine work as far as roughing out is done on this block. I checked on my deck height and I'm probably within a thousandth of the other side. I'll check that again as I roll the block over just to make sure. But one last thing I want to do is check the surface finish, because as you recall, we're going to use the Cometic multi-layer head gaskets on this, and we need to be under 50 RA to have those gaskets sealed properly. So we'll run our check here, see what comes up. It's making its way across there. Come on, come on, come on. Should have a reading here very soon. There it is, 27 RA. Absolutely acceptable for a multi-layer head gasket. As recall, I think our heads are probably in about the same range. So things are looking good. Let's get this off here and into the hone and finish those cylinders. So this evening I think we'll see if we can get started on honing this 350 block. It is a 30 over block. We're doing up here with a flat tappet cam, kind of to compare how it's going to work against our other block we're doing for that Camaro with the roller cam. I want to see just how much difference there is between two similar engines with just a different camshaft. I do have the mains already torqued on this block, so we need to mount it here in the hone. I think I need to chase the head bolt threads before we put the torque plates on. I actually have the caps left in here from the last 350 I did. I need to put those with the block that they belong on. So let's start with this side right here. I think I'll back that out like that. It's a little better angle for me. And I want some lubrication on those as I go through with the thread chaser. Okay, that's that side there. I think while I've got that out, I'm just going to go ahead and do the other side at the same time here. Use that. I think that'll work better for cleaning those threads up. And I don't have any dowels in there, so we better find some of those and install. And install guide plate, or guide plate, torque plate. Okay. You always want to kind of start the bolts before you start drawing it down at all. Sometimes they are off enough that they want to bind up. And now we'll torque them. And we need to change the stones on the hone head here, because this will have the finish stones in it right now. All right. Put the spring back on the bottom. Okay. And we need to set up our bore gauge. I'll be right back. So my bore gauge is set to exactly 30 over now. That's where I want to finish this block to. Okay, let's see if we're ready to go. Okay, oil's flowing. Okay, we're off. Okay, let's stop right there and see where we're at. Okay, looks like I still have better than 3.5, probably closer to 4 to hone out of that. If I set this, what I say, 3.5 anyway, if I set this on 7 and hone to 0, we should be real close to size. And I think I'll just speed this up because there's not a lot to see here. So let's do a little bit of fast forward. Okay, let's see where that got us to. We should be very close to our finished size. We are within about 3/4 of a thousandths of being to the finished size. So I'm going to adjust that up maybe 1 notch closer. Before I do the next hole here. Slightly more than 1/2 thousandths more. So here goes. Let's see how things look on this cylinder after having made a minor adjustment there. That's looking real fine. We are within about 2/10 at the bottom. 2 to 3, probably 2. To about 1 to 2 at the top. I'm happy with that. Let's keep moving on. So I've finished with the rough hone on the first 4 cylinders here, and you can see that each one is within a couple tenths or less of being at 0, which is my finished size. So now I'll change over to the finer stones and we'll make a few strokes and get our final finish. All right, my next step here before I move on is to go through the cylinders with the profilometer here and make sure that the method I have used here of rough hone and finish hone is getting me the correct finish on the cylinder walls. So this little tool that I just put down inside the cylinder here has a little stylus on there that when I turn it on moves real slowly up the side of that cylinder wall, and it will record for us here the roughness of the cylinder. And what you want is some rather deep valleys to hold the oil, but the peaks flattened off so the rings have a nice area to sit on. And this looks like I came right in the range where I'd want 14 RA, 32 RK, 13 RPK, and 51 RVK. So I'm going to record that here so I can keep track of that as I go. So I won't bore you with all that right now. We'll just kind of buzz through here in a hurry. All of my numbers for the finish I got on those cylinders were right in the range of where I want. So let's roll this block over, switch torque plate to the opposite side, and we'll finish those cylinders. Okay, this is going to look an awful lot like the block I just finished, but it's actually the 350 for the Camaro. These two are just like. Just well take care of them. I've found over the years if you just kind of wiggle that as you snug it down, it centers up just a little bit better. Now then, I did run into a snag on this. You know, we were so careful going through to make sure that this block would clean up at 20 over. And I think maybe you can see here there's one shadow there. Let me bring this in real close so you can see that. It didn't quite clean up with the boring bar, but I figured that would easily clean up in the hone, and I did measure it at the time and determined that it should clean up. But there was one website showed one set of pistons in stock, and I hurried up, got this done while they were still showing in stock, placed my order, and won't you know it, the next day I get a phone call that says, hey, we can't find those 20 over pistons. All we have is 30s. And I said, well, thanks a lot, because I just wasted my time making this block 20 over. So rather than going back, setting it back up on the boring machine and taking an additional 10 thousandths out, we're just going to do it right here with the hone. I think we can do that probably just about as easy as setting it back up on the other machine. So let me get the torque plate on here, and we'll switch the stones over to the coarse stones, and we'll get started honing on this. So I finished honing on these cylinders here, and I want to go in and check my size one last time. I need to be at least 0 and as close as I can, so I'm within 2 10,000ths over there. 0, anywhere from 0 to 2/10 in that cylinder. 0 to about 1/10, 0 to about 2/10. So I'm happy with the way the cylinders came out. So now I need to take this torque plate off this side, flip it over onto the other side, torque it back on, break this loose with the ratchet. Should be able to use the drill to spin these out of there. And with that, we should be ready to start honing. Over 14 thousandths we're going to have to take out. So I've finished the right bank of this 350, and we're going to check our finish on the cylinder walls. Okay, 33 RK, 13 RPK, and 54 RVK. You know, Nicholas is the one that has a much better understanding of what all these numbers mean. But if nothing else, right or wrong, our numbers are very consistent. I really am surprised at how consistent our finish is from one cylinder to the next. Okay, 16, 35, 13, and 56 on the RVK. All right, all those are within the range of what Nicholas has told me we need to attempt to achieve. So with that, I'm going to take a torque plate off and consider this block finished. So now that the machine work is all done on this 350 block, I'm going to take the main caps off before we wash the block. That way we can get it absolutely clean. There. Now we should be able to properly clean this block. Time for the final wash on this Camaro engine. We'll give it about 30 minutes. Let's stop this spray cabinet partway through the cycle. I'd like to run a brush through the cylinder bores, make sure they're as clean as we can get them while it's in here. I think running the brush through will maybe loosen up a few more particles, and then we can finish the wash and they'll clean a little bit better. This is not a brush hone. This is truly just a bristle brush. Sole purpose is to clean the cylinder bores a little bit better, make sure all the grit and loose material has been removed. Put her back in and finish running the cycle. So the spray cabinet has just shut off to run its complete 30-minute cycle, and I think we can get this block out now. Give it a good rinse, and it'll be ready to start some assembly work. And that is hot. Whew. I've had employees in the past, when we were running a bigger operation here, think I was being skimpy on the water bill and not allowing them to use much water to rinse. But in reality, we have to conserve on our water because we are running a closed loop system here. We do not drain any water or solvents or anything outside the shop. It all stays right inside here, and one way or another gets recycled back around through the machines here. So I have a very small nozzle here on my rinse hose that actually helps because I can get this nozzle down in the bolt holes and rinse all the threads out real well. But the main reason here is to conserve the amount of water we use, because the only way we can get rid of water here is through evaporation. When I'm rinsing off a block like this, I try and make sure I get down inside every single bolt hole, every single oil gully. It doesn't matter if it's, for instance here, just a motor mount bolt hole or a heat shield bolt hole. I still want to get down inside, clean it out, so when you get ready to assemble this motor, or get ready to install this motor, not only for the assembly, but also when end customer gets ready to install this motor, they don't have trouble with not being able to get bolts screwed in where they need to be. Uh-oh, somebody forgot and left one in there. I'll have to take that out and do a little cleaning after the fact here. And this is also a good time to look the block over one more time and make sure all the threads are good. And for instance there, I noticed that there was one that I had missed removing. It seems like no matter how many times you wash out or blow out the water jacket, there's always more casting, flash, rust, chunks of, sometimes you'll find old freeze plugs that someone had replaced where they just drove the new one into the water jacket, never even removed it. And let's take our brush and go through the cylinders one more time. Our shop here operates off a well. We do not have public water here. We have our own water source. Water tastes real good, but it is pretty high in salt content. And that's one of the drawbacks with cleaning blocks here with it, is it does cause them to grow surface rust almost immediately after coming out of the spray cabinet. So we have to make sure that we blow everything off and dry it as well as we can. Colorado air is pretty dry. As long as we dry that block after it comes out, it will not rust like blocks do in some areas. So I will lift this block out of here. And I'm going to proceed to blow that out, dry it off. So hold your ears. Gets noisy.
Well, it looks like the cleaning guy lost audio for some reason here at the end of this video, but we want to say thank you guys for staying till the end of the video. Thank you for watching. Be sure to click that like button, drop a comment, and subscribe if you're new here. Check out the merch link in our bio, and we'll talk to you next time.